Okay, in one of the previous videos, we looked specifically at electron configurations, and I did kind of a quick orbital energy diagram for fluorine, but I want to do that more carefully with the examples in this video. So we're going to draw orbital energy diagrams. So just a couple reminders. We want to be aware of the ordering of the energies of the orbitals when we're filling them up and when we're drawing orbital energy diagrams. And things can get complicated as we get in this region and the energies of the orbitals get close together. But as we talked about in that electron configuration video, the periodic table tells us what the ordering is. And so the rows tell us the principal quantum number. We have the S block, the P block, the D block, and the F block. And so we can use that to determine the ordering of the orbitals. If you want a refresher on that, go back and look at the video on electron configurations. Alright, so if we want to draw the orbital energy diagram for oxygen, what I usually do is start by writing down the electron configuration. So I would go to the periodic table and find oxygen. Right, and then for oxygen, we have the 1s, the 2s, and the 2p's. And oxygen is in the 1, 2, 3, 4th column of the p block. And so it's going to have 4 2p orbitals. And so the electron configuration for oxygen is 1s2, 2s2, 2p4. So here's the electron configuration we found. So now if I want to draw the orbital energy diagram, so first what we want to do is label the y-axis. So the higher we write the orbital, the higher in energy it is. And the 1s is going to be the lowest in energy. The 2s is going to be higher in energy than that. And the 3 2p's orbitals will all have the same energy, and they'll be a little bit higher than the 2s. And so when I draw them, these 3 orbitals are degenerate. They have the same energy. So let's label these. I have the 1s, the 2s, and the 2p's. And so I want to fill up the lowest energy orbitals first. That's the Aufbau principle. I can only put 2 electrons in each orbital. That's the Pauli principle. And when I put the electrons in, if they're in the same orbital, the 2 electrons have to have opposite spins. So one has to be spin up and one has to be spin down. And so I represent the spin by drawing the electrons as sort of half arrows. And so I only drew 1/2 of the head of the arrow, and that one I have pointing up, indicating spin up. And that one I've drawn the half arrow down, indicating spin down. So I've done the 1s2, and then the 2s orbitals, or orbital, gets 2 electrons, one spin up, one spin down. And when I go to put the 4 electrons in the p orbitals, due to Hund's rule, every orbital gets 1 electron before any gets a second one. And when I put the electrons in the degenerate orbitals, they all go in with the same spin. So when I put in my electrons, I put in the first one, spin up. The second one goes into the next orbital, spin up. Then 3, and then the 4th one, I can now start pairing, but it has to go in spin down. And so that would be the orbital energy diagram for oxygen. All right, let's do one more, and then I have another video with a third example if you want yet another example. In this case, let's do the orbital energy diagram for iron. Again, probably the easiest thing to do is find iron on the periodic table. So iron's right here. Right, so the electron configuration is going to be 1s, 2s, 2p, 3s, 3p, 4s, and then iron is in the 3ds, and it's in the 1, 2, 3, 4, 5, 6th column of the ds, so it's going to end up as 3d6. So the electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d6. Alright, so I've got the electron configuration rewritten here, and I'll label my y-axis. And then we start with the 1s orbital again. Right, then the 4s comes next in energy, and then the 3ds are going to be higher than that. And there'll be 5 d orbitals. Alright, so until I get to the 3ds, everything's going to be full. So all the electrons will have, or all the orbitals will have 2 electrons. So, right, putting them in with opposite spins. And now there's 6 3d electrons. So again, every one of the degenerate orbitals gets 1 electron before any gets 2, and they initially all go in with the same spin, so I'll put them all in spin up. So 1, 2, 3, 4, 5, and the 6th one I can pair. And so that would be the orbital energy diagram for iron.